Hi, everyone. My name is Jeff Wilkerson, an astrophysicist at Luther College, and I'd like to take a moment to tell you a little bit about astronomy and astrophysics here at Luther. I've been here 23 years. I came from the University of California. I'll tell you a little bit about how I got my start while there. Uh, I was a TA, a teaching assistant, my first year of graduate school. And all of those of us who were going to be teaching assistants, they got us together in a room the day before the semester started and said, hey, you teach tomorrow. You have any questions about that? And of course, we didn't have any questions about that because we hadn't thought about teaching for a moment. We were all there to do the big experiment, to learn the great thing about the universe and figure out how the universe works. We hadn't actually thought about teaching. So I went into that first classroom. I was teaching an algebra-based physics class, a discussion session, a problem-working session, and students got to the board, started working problems, and we were working problems there together, and it was like a light bulb went off above my head. I thought, whatever I do for the rest of my life, I hope this is part of it. And as I worked my way through graduate school and as a postdoc in astrophysics, I spent some time at the Lawrence Hall of Science developing planetarium shows. And I knew that I wanted to get someplace and taking telescopes out to the community to look at the night sky. I wanted to get to someplace that was a nice small school with close interaction between the faculty and the students so I could continue that initial feeling that I had when I went into the classroom. And I also could keep delivering and developing planetarium shows. So I was looking for a place with a planetarium and a place with good dark skies so I could keep having access to the night sky and share that with students in the community and others. I was fortunate enough to land here at Luther College, and I've been here ever since. And so I'm going to tell you just a little bit about what we have going on there. So I'm going to show you a little bit of a slideshow and talk over the top of it and let you see a little bit of what we have happening here. So one of the things with astronomy and astrophysics here is we have a couple of courses. We have an introductory astronomy course, and we have an astrophysics course for the physics majors. The astrophysics course we've taught both as a regular course and pretty commonly as a course by arrangement, where 2 or 3 students can get together and we can work through some books and some laboratory exercises, and we can learn astrophysics together, sort of just 2 or 3 students at a time, working somewhere between independent study and a regular class. We did this past January term with 2 students, and it's usually a pretty good experience. A lot of it is project-based, working with data that we've acquired here. There's the entrance to the planetarium that you see. And that's the planetarium that I was looking for when I moved here. We still have that available. Now we have that as an opportunity, a work study opportunity for students to present shows and develop shows in the planetarium. And so this is a great resource for the community. The other thing that we do here is we have an ongoing research project. So once I was here, you see the observing deck that's on top of the roof over here, small little picture, several telescopes set up. The telescope that's right here in the left of this picture is our research telescope. We shoot pictures of this field of the sky. M23 is an open star cluster that's included in this field. M23, the open star cluster, only has about 400 stars in it, and there are 1,600 stars to 1,650 stars that we can see on a regular basis in this image that we monitor. We measure the signal, the brightness from in a given night. We measure the brightness many, many times, hundreds of times to a couple of thousand times of each individual star in there. And then we find the average brightness over the night to look for slightly longer term things. So we have really unprecedented coverage of a single patch of the sky like this. A lot of stars, a lot of images in one night to look for things that are happening on short time scales, and then a long data throw. We've been doing this since 2003. So we have years and years of data to look for subtle things that have been happening as we've watched the sky here. We can see that patch of sky from about February till October, and then it slips behind the sun, and we're able to get a little bit of rest and do a little bit of data analysis and computer code writing and try to catch up somewhat, and then it rolls right back around and we start again. So we're having a pretty good year here, and I'm doing this in 2020. We're having a pretty good start to the 2020 data season. This is April, and we've already acquired almost 20 nights of data here. So this is going pretty well for us. You see this table is just all of the data over all of the years. Getting close to having 1 million. When I say usable images, I mean images that have passed photometric quality tests. So the night turned out to be good enough so we can actually measure the brightnesses of the stars with sufficient quality to use it in our research. Most important part of that is, man, a lot of great students have participated in this project over the years, and we've done great things, and they've all gone off and done really, really interesting things. A great many of them have gone to graduate school in physics, engineering, or astrophysics and earned master's degrees or PhDs, and a great many of them have gone on and done other interesting things. Some of them are teachers, some of them are engineers. Who working in various different fields and doing a lot of different things. And really the beauty of this project, is we have so much data and so many different things that we can look for in there and so many new statistical tests we can develop. There are always interesting projects bubbling out of this. Here's an example of a project that's one of, I'm going to show you 3 main types, although there are many more, of things we work on. We have figured out that there are about 70 or 80 what we call long period variable stars. And these stars oscillate. They're asymptotic giant branch stars, post main sequence evolution, and they oscillate with periods that range from tens of days to hundreds of days. And you can see on the right here, this is 1 year, 2015, one particular star. And you can see it had a pretty clean oscillation this year. Other years it has a less clean oscillation. But you see it from about date 4300 to date 4500 or so, we got almost 4 full oscillations, maybe 4 full oscillations in there. So it appears to be oscillating with a period of about 75 days. But it's got other periods there. So it's multi-periodic. There are other periods of oscillation that are happening. So some years aren't nearly as clean as that. It looks like it's jumping around all over the place. This star is also an example of many other things we're looking for in these 70 or 80 long period variable stars. Is there a long secondary period with thousands of days where the star seems to be getting brighter or dimmer? Or is the star getting dimmer overall or brighter overall over the course of 20 years that we've been looking at it? 2003 out here, 2020 out here. And the other thing that's interesting about this star, this is one of about 6 of those 70 or 80 stars that we call sudden amplitude shift stars. Don't know anything about these stars, not seen anybody else talk about these stars, and we're trying to understand what's happening with these stars. We're trying to understand what's happening in a lot of ways. Do these stars evolve the frequency? If they have a lot of different frequencies, do they evolve from one frequency to another? Do they get bigger amplitude, larger amplitude of oscillation? You see the amplitude of oscillation up this way. Look at how it spiked right there, and look at how it spiked again right there. But some years it has a very small amplitude like you see right here. So some years it's nice, clean, tight amplitude, and then suddenly it'll have an outburst where it gets big amplitude. One model we have is that as the frequencies, if it's got a lot of different frequencies of oscillation interfering with one another, that keeps the amplitude down. And if some of those disappear from time to time, you get these bigger spikes. We don't know if that's a good model or not. It's one of the things we're testing and we're working on as we try to understand stars like this. You see there's a histogram of the amplitude, the size of oscillation of the stars that are in our field, these long period variable stars, and you can see most of them have a very small amplitude. This is the magnitude system that astronomers use, and we would say that these stars are a different category than these stars down here. We're really trying to fill in this low amplitude side and understand what's going on down here with these smaller amplitude stars that maybe people haven't had a chance to study as much. That it's an advantage of us having dark skies and access to this telescope all summer long, every summer, to be able to fill in this part of the histogram. Do these stars evolve from lower amplitude to higher amplitude, or vice versa? Do they evolve in their period mixtures? We talked about them having different frequencies of oscillation. The ratio of the periods of those different frequencies tend to fall along these bands. we're curious. Do stars start here and evolve up this direction to different higher frequencies, or do they not? So that's an interesting question that we have. Other thing we look for in these, with all that data, we can see what looks like flare events. Now, most of these flare events, this is a single star on a single night. It got brighter for about an hour and then faded back away. And most of these things turn out to be noise, just hard to evaluate noise in the system. And that noise we have to throw away. We're looking for the needle in the haystack that is not caused by a satellite going through or bad calibration of the data or whatever it is, where it looks like we can't get rid of it for any reason. That's a real astronomical event. And this is one of maybe 4 or 5 is all that we found over those 15 years. And this is from a student's senior project fitting that brightening event as a microlensing event, gravitational microlensing, where an object in the outer solar system might have curved space and worked as a lens and caused light that would have missed us to get curved towards us and hit us and make the background star look brighter like that. Is that what's going on? Heck, we don't know. There's a lot of work to be done in there that's interesting to try to figure that out. Another category of objects is an eclipsing binary star. This is one of half a dozen that we see in our field of view right there. That is a beautiful, beautiful eclipse. And this eclipse looks like this, where we have the two stars. One star passes in front of the other star, blocks the light from the other star, and you see something that looks like this. From this, we can measure the radii of the stars and the relative brightnesses of the stars and learn quite a bit about the stars. And one of the interesting things, that's our star, one of our stars again. And one of the interesting things about this is that all of those long period variable stars that we were looking at that were pulsing in and out, they all appear to be beyond that cluster M23 that I told you about at the beginning. All of these eclipsing binary stars appear to be in the cluster. So a rich stellar environment, a dense stellar environment where there's lots of stars, and these all have very short periods of less than a day. So the orbital periods of these stars around each other are less than a day. And we're interested in how those periods might be evolving with time. As mass might get transferred from one star to another or move from one star to another. So we're looking in changes where the eclipses occur at times different than we're expecting, and measuring these sorts of things going on in these stars. But we're also now interested in how these stars came to be. Why is it that there are 6 of these short period eclipsing systems in our cluster and none? 400 stars in the cluster, 6 of these, 1,200 stars not in the cluster, none of these. And so we're interested in the gravitational dynamics that might give rise to this kind of system. So that's a pretty good overview of some of the things that we're talking about here, that we're working on at Luther College and trying to understand with our research work, in addition to the courses and other things that we do. I'd love to talk to anyone more about the work that we're doing. A couple of things. You can go to astronomy.luther.edu and read a little bit more about any of these projects. But please just send me a message and I'd be delighted to talk to you about it. It's WILKERJE at luther.edu. Just really excited to have done this work with so many good students over the years, to think about some of those light curves that we showed you. Nobody else has seen those. The students and I have been working in the lab on those, and it's really an interesting thing when we look back at these stars and try to answer these questions that we're answering, to say every one of those stars, when we see that star varying in brightness, we're the only people in the world who know that's happening. We're the only ones who know that this particular star that we're looking at is doing something really interesting. One of these sudden amplitude shift stars. Not only is it oscillating, but it's oscillating and it's suddenly just, it blows up, and we don't know why. And that's our little playground to sit and work with, and it's been my pleasure to do that with students over the years. So please let me know if you want to learn more about it. I'm happy to talk more about it. Thanks for taking time to listen to me jabber about astronomy here at Luther.